So today we're going to be learning about the chain rule, and the chain rule is useful when we have something that is a function of a function. And this crops up more often than you would think. So let's look at a fairly typical example of motion where we have a guy getting run over by a skateboard. Now I know that when this skateboard starts to roll with that big filing cabinet on it, it's going to accelerate. So there we go, and watch out, watch out. Oh! Another thing I know about this motion is that as the angle increases, the acceleration is also going to increase. So watch this. Watch out, watch out. Ooh. The steeper the angle, the greater the acceleration. So acceleration is a function of the angle of the ramp. I can express this symbolically. A equals some function of theta, where theta represents the angle. And if you're lucky enough to be taking physics with us, you will know that acceleration is actually 9.8 times the sine of the angle theta. So let's consider a second confounding factor. What happens to acceleration, which is a function of angle, if angle is changing as a function of time? And so if you watch, the angle of this ramp is going to be steadily increasing with time. So what happens to acceleration if the angle is also changing as a function of time? If you watch this carefully, the angle is changing steadily as a function of time. And so I already know I have one function, acceleration being a function of the angle, and the angle is a function of time. What happens if I want to know how acceleration is changing with respect to time? That's where I have to chain these two functions together, and that's where I need the chain rule. And so if I want to know how acceleration is changing with time, and in calculus I ask that question this way, what is dA dt? I have to go through how acceleration is changing with angle first. In other words, I have to find dA d theta, then I'm going to find out how angle is changing with respect to time, and what I end up with when I multiply those two together is how acceleration is changing by time. And you can kind of see it's almost like one of those nice canceling equations, except it's a little more complicated than that.